The next main system is the lungs of the engine, the twin turbocharger package seen here on the right side of the engine. Up close, you can see that there is one large and one small turbo. And here is an example of a small turbo, and here's the large turbo. Now, the turbos operate in sequential manner for smooth power delivery and a very flat torque curve. Sequential means that the small turbo operates at low engine speeds, then both turbos operate at mid-range speeds, and the large turbo operates at higher engine speeds. Twin turbos are, of course, expensive, and as you might expect, the next big step in development will be to get the same seamless performance with only one turbo. These next 4 slides will show you the sequences for the twin turbo system. In the schematic, the blue flow indicates intake air, and the red flow indicates exhaust. You can see the large and small turbo and 3 butterfly valves here shown all closed at low RPM. In this mode, all intake air goes past both turbo compressor wheels, and all the exhaust goes past both turbines. The small turbo, with its lower inertia, is spinning very fast and providing some boost. In this sequence, we see that at about 1,500 revolutions per minute of the engine, the turbine bypass butterfly valve for the small turbo begins to open. This allows more exhaust energy to reach the large turbo and get it spinning faster. Both small and large turbo are now providing a share of the boost. At mid-range engine speeds, the turbine bypass for the smaller turbo is fully open, and the large turbo provides the boost. At high speeds, the turbo can put out much more boost than needed, so a wastegate valve opens and some exhaust can bypass the turbine to prevent overpressurization. In summary, the large and small turbo work together in sequence to deliver seamless performance through the full range of engine operation. The next major system is the exhaust system, and it plays a critical role in minimizing emissions. Efficient pollution control means that the exhaust must pass through 2 catalysts and 1 particulate filter. Here's a schematic of the system. If you start from the left, the exhaust leaves the engine and turbochargers and enters an oxidation catalyst. It's a 2-way catalyst that reduces carbon monoxide and hydrocarbon emissions. 2-way simply means it reduces 2 separate pollution gases. The oxidation catalyst is placed close to the engine so that the exhaust is hottest and the cleanup reaction is improved. Oxidation catalysts are typically made up of a ceramic honeycomb with a thin coating of a precious metal like platinum. They're very expensive, and of course we want to reduce the use of platinum in any of our components. The same canister holds a particulate filter that collects and burns up soot and larger carbon particles. A particulate filter is usually made up of a special ceramic honeycomb, so it holds the soot in a kind of a screen so it can heat up and completely burn. From there, the exhaust passes by the SCR dosing module, where a computer control will periodically send a signal to inject some diesel exhaust fluid, or DEF, into the exhaust gases. This mixture passes through a finned mixer plate, then into the SCR catalyst, where a chemical process changes NOx, nitrous oxide, into harmless nitrogen and water vapor. Here's a simple explanation of the chemical process. When the diesel exhaust fluid is injected into the hot exhaust, 2 things happen. The heat of the exhaust changes some of the urea into ammonia and isocyanic acid. Then the water vapor in the system changes the isocyanic acid into more ammonia and a small amount of CO2. This ammonia, NH3, enters the selective catalytic reduction catalyst and selectively combines with the nitrous oxide NOx. When the NOx and ammonia combine, they form harmless water and free nitrogen. the SCR catalyst is acting kind of like a docking station to help bring the ammonia and the NOx together. The result is that practically all of the NOx is converted to nitrogen and water vapor. Now that you've seen how the heart, the lungs, and the exhaust of the engine work, you might be wondering what else is unique to the diesel engine for the USA. Here's a quick rundown. For noise reduction, unique to the United States, the wrist pin locations in the pistons are offset. Now you may know that the pistons are connected to the connecting rods and go up and down. Well, the connection of the piston to the connecting rod for the US is slightly moved toward the cylinder wall, and this slight offset means that the piston has less of a tendency to rock in the power stroke, and therefore it's quieter. There's also, for the US, a cast reinforcement on the bottom of the engine crankcase that covers 4 of the main bearings and adds stiffness for noise reduction. There's also a noise reduction panel under the engine compartment. Also, unique for the US, the crankcase ventilation system is heated and monitored to make sure that it's always attached. The torque converter in the transmission has twin axial spring dampers that smooth the flow of power when the transmission coupling is locked up. Now, because a diesel engine uses fuel so efficiently, there's very little heat released to the coolant at low power outputs. This means that sometimes there won't be enough hot coolant to heat the occupant compartment in winter. As a supplement for the normal heater system, the X5 and 3 Series diesel models for the US have an electrically activated ceramic boost heater element positioned in the heater box as shown with the arrow. When coolant heat is not enough to warm the occupants, excess electricity from the alternator is sent to the heater to boost the output. Now, to stimulate improved combustion, there are also electrically operated swirl valves in the air intake ports shown here circled. To reduce the production of NOx, nitrous oxide, during the combustion process, the 335D and X5 diesel both have a high-pressure exhaust gas recirculation system, or EGR. Because it has towing capability, the X5 diesel also includes a low-pressure EGR, and you can see them here on the engine. This is the low-pressure EGR exhaust gas recirculation, and this is the high-pressure exhaust gas recirculation valve that's unique to the X5. Both the low and high-pressure EGR systems are water-cooled by the engine coolant for improved efficiency. The DEF, or diesel exhaust fluid, for the SCR selective catalytic reduction system is stored in 2 separate reservoirs. There's an active and a passive reservoir. Shown here in the illustration are the active reservoirs, which are both heated because the diesel exhaust fluid liquid will freeze at temperatures below about 12 degrees Fahrenheit. So the active reservoirs supply the needed DEF, diesel exhaust fluid, and the passive reservoirs act as a backup to refill the active reservoirs as needed. And last but not least, we come to the misfueling protection system. To reduce the chance that gasoline is mistakenly filled into the diesel fuel tank, there's a misfueling protection system installed. Now, a standardized gas station nozzle is about 21 millimeters in diameter, and a standardized diesel fueling nozzle is about 24 millimeters in diameter. So if a nozzle smaller than the correct 24 millimeter diesel nozzle is used, a flap stays closed in the fuel filler pipe and prevents filling with gasoline. The misfueling protection won't let the flap open unless the correct 24 millimeter diameter diesel nozzle contacts 2 release buttons in the fuel filler pipe and releases the flap lock. Rudolf Diesel invented the engine, but we made it become a true BMW engine, the ultimate driving machine. Thank you very much for your attention.